Alright, sorry guys, I believe there was a problem with my phone and we could not record, so Mustafa's put on his phone and we'll do the recording from there so that we can give you the full recording on YouTube a few days later. Alright, so we said barbiturates and other drugs that induced cytochrome P450 system can lead to the activation of ALA synthesis. Activation of cytochrome P450 system leads to decreased heme levels, which results in enhanced ALA synthesis activity. The use of these drugs can precipitate the clinical manifestation of porphyrias. Alright, now you can pay attention to this biochemical structure up there and we'll take it further. You're coming back to succinyl coenzyme A and glycine are combined with ALA synthesis to form alpha amino levulinic acid. So I'm going back to synthesis. Amino levulinic acid subsequently dehydrated by ALA dehydrogenase to form porphobilins. Porphobilinogen deaminase catalyzes the concentration of 4 porphobilinogens to form a linear tetrapyrrole. So this is a little bit of biochemistry. You can take a look at it. So here we come to the heme degradation, which is important. So you've got your erythrocyte and you've got a little bit of destruction of Kupffer cells and you've got the breaking down of heme. So heme breaks down, hemoglobin breaks down to heme and globin, as you can see. Heme breaks down further to give you iron and bilirubin. And your amino acid, your globin breaks down to give you amino acid, which is used again by the body, as is the iron. Now this bilirubin is the unconjugated bilirubin that goes to the liver, and the liver conjugates a little part and all the rest of it is got rid of through the common bile duct to the intestine to the feces. And we'll take a look at this again. Your liver has the enzyme 2,3-UDP, and that is the reason why your unconjugated bilirubin, which is attached to albumin, comes to the liver. A little bit is transferred. So here the indirect bilirubin becomes direct, and most of it is got rid of through the biliary tree to the intestine. A little bit is regurgitated back into the blood. That's the reason why your normal and my normal bilirubin is about 0.2 to 1.2. And that is the reason why the color of stool is brown, stercobilinogen. We're coming back to the breakdown again. So after 120 days, the red cell is broken down and therefore the hemoglobin breaks down too. Hemoglobin then splits up into heme and globin. Globin chains are further broken down to amino acids, which goes into amino acid pool to be reused by the body. Heme is broken down by iron and protoporphyrin. Iron is always in the +2 stage. Iron goes to iron pool to be reused. Protoporphyrin is further, the ring opens up to give an indirect unconjugated bilirubin. This bilirubin attaches to albumin and travels to the liver. Okay. We continue. In the liver, part of indirect bilirubin is converted to direct by the enzyme 2,3-UDP. Most of it is got rid of in the intestine and out of feces as stercobilin. Small fraction is regurgitated into the blood. The reference ranges are total bili 0.2 to 1.2, direct 0 to 0.5, indirect is the less. This will help you differentiate different types of jaundice depending on which fraction is elevated. I hope your memory will give you that information. So we go further. Hemes are cyclic tetrapyrroles that contain iron and are commonly found as a prosthetic group of hemoglobin, myoglobin and cytochromes. The small molecule component of globins, critical for oxygen transport among other functions, undergoes a complex process of metabolism and degradation. Roughly 80% of heme destined for degradation and excretion comes from senescent erythrocytes, which have circulated over an average of 3 months. The other 20% comes from premature erythrocytes in the bone marrow, which are destroyed prior to release in the circulation, and a minor component is derived from other cell types. Various components of heme degradation occurs in cells of the reticuloendothelial system, liver and intestine. The substrates are heme, NADPH, 2-UDP, glucuronic acid. Urobilinogen is then excreted in urine, stercobilin excreted in feces. The degradation continues. Degradation begins inside macrophages of the spleen, which remove old and damaged erythrocytes from circulation. RBCs are engulfed by cells of the reticuloendothelial system. The globin is recycled into amino acids, which in turn are catabolized into intermediates of citric acid cycle and fatty acid. Heme is oxidized. The heme ring is opened by heme oxygenase. The oxidation occurs, on which gives the feces its color. We go further, a specific carbon producing the linear tetrapyrrole biliverdin ferric iron complex with carbon monoxide. In the next reaction, second bridging methylene is reduced by biliverdin reductase producing bilirubin. The green pigment is thus converted to a red-orange bilirubin. Are you be able to hearing me properly? Is the audio clear?
Yes.
Okay.
Yes, ma'am.
Okay. All right, we go further. Bilirubin is then transported in the serum by albumin to the liver, where it is conjugated by gluconate, by bilirubin gluconate transferase and excreted in the bile. In the intestine, bilirubin is deconjugated and converted to urobilinogen and stercobilin. Some urobilinogen is reabsorbed and excreted as urobilin in the urine. Most urobilinogen is oxidized in feces to stercobilin. And I think you know that when you dip your strip in the urine, there is a little bit of urobilinogen that you and I should have. The significance of this is free heme concentration greater than 1 micromole can be toxic because it catalyzes the production of reactive oxygen species. To cope with this problem, heme degradation is very crucial for the body. In animals, this pathway is an excretory system by which the heme from the hemoglobin of aging red cells and other hematoproteins is removed by the body. And that's about it. This is just a little bit of revision to give you a little picture of what is hemoglobin, its build-up and its breakdown. I've tried to make it as simple as possible. I haven't gone too much into the biochemistries, but I think it's something that is quite simple. Anybody who would like to discuss it,